Science in the news then. Ferrofluids. The reason I wanted to talk about ferrofluids really is because I think they're a lot of fun to play with, although they're a bit messy. So, what are ferrofluids? Well, they've been around for about 50 years. They were invented by a NASA engineer to get rocket fuel in zero gravity into the fuel pump by applying a magnetic field. So a pretty clever idea, really. They're man-made in the sense that ferrofluids are not found lying around in nature. They're nanomaterials. The particles are in the nanoscale, 10 to the minus 9 meters. And they are super paramagnetic. What that means is that they're only going to behave magnetically in the presence of a magnetic field. And that's something that only happens on that nanoscale. So what are they used for? Well, they have been used as a seal on hard disks, for example, placing a dust seal around rotating shafts, for example. They're used in the semiconductor industry, aerospace. They're used in loudspeakers and shock absorbers or dampers if you're not from the UK. And one of the projected uses is in haptic feedback in touchscreens, giving texture to that touching experience. And they're very good conductors, so used in heat dissipation in electric motors. Pathogen detection, this is really interesting. They can find and collect pathogens. The details of this I will leave you to look up for yourself. I'm giving you an overview of this, but it's very interesting stuff. And hyperthermia, the use of heat to kill cancer, providing localized heating. And an MRI. The idea with hypothermia is that you can put your ferrofluid into the tumour and then you can apply a magnetic field and cause localized heating. And an MRI, as I said, as a contrast agent, essentially it enhances the image brightness. Another use of these, you may well be aware that diesel engines produce a lot of microparticles. These are particularly dangerous from a health perspective, and the trap prevents them from entering the atmosphere is the idea. But these traps get blocked up and they self-clean by heating to a temperature of around 600 degrees C to burn off the soot. But they do that by increasing the exhaust gases. But the ferrofluid, by adding that to the fuel, you can decrease the temperature at which the soot burns off. And that means that you don't have to have this separate regeneration process. The regeneration occurs if the car is running long distances normally, then it'll happen anyway. But if you're doing lots of short runs around town, the soot can build up and the car will detect this and then inject fuel into that chamber to burn it off, perhaps. There are several ways of doing it. That's one way of doing it. And if it builds up too much, then you need a garage, and that can be expensive. Adding the ferrofluid to the fuel then reduces the temperature at which the soot will burn, and that temperature is one that the engine normally runs at, or the exhaust is normally at, and so the problem is solved. So what else is on the horizon for the use of ferrofluids? Drug delivery. Using ferrofluids as drug carriers in targeted therapy, the idea is that you can use the magnetic field to draw the drug to exactly where you want it to be. This then, for cancer treatment, for example, will reduce the side effects compared to conventional chemotherapy because the drugs are only going where you want them to be. And so they're not doing the wider damage that chemotherapy drugs do. Drug discovery, ferrofluids are used as an effective, convenient and faster way to identify and isolate useful molecules from plants where many of our drugs come from. So that's quite exciting. And cell and gene therapy. Cell therapy, as you may know, involve stem cells or immune cells, and the migration of these cells is monitored using MRI, and the ferrofluids help with the contrast medium. They are the contrast medium to allow a greater brightness in the image, and therefore very useful in supporting cell and gene therapy. So this is Ferrofluid. I bought it from First for Magnets, where most of my magnets have come from. The spherical magnet you're going to see was a present. I'm not quite sure where that came from, but the other magnets came from First for Magnets, as did the ferrofluid. So the ferrofluid behaves just like a black sludge when not surrounded by a magnet. Well, here's a pen. It's got a metal barrel, and nothing happens when I bring the pen near the ferrofluid. But here I have a spherical magnet. Watch what happens when I put the spherical magnet underneath. You can see that the field lines of the magnet are being followed by the ferrofluid. I'll just take this off again. So all I've done is to put the ferrofluid into an old food container. Let's try putting some magnets on this end. And you can see the field lines followed there. Let's put some magnets on this end. And you can see the field lines there. So this is great fun. And if I put my spherical magnet in the middle there as well.